Okay, I thought it was a good question, and they tell me they got three roots. Well, it's a cubic polynomial, you expect that. Real roots too, because they're greater than zero, so R1, R2, R3. And it says find the area of the triangle's sides are, R1, R2, R3. Now, certainly, the way I go through it, you may disagree with this. One thing you could do is just simply solve this for the three roots, and then get the area. And one way to get the area is just use Hero or Heron's formula. So I went through the work. I used some things that certainly, depending what schools you attended, a more maybe I should say better school, but a more aggressive school, one that's where students are more engaged with the material. They might be presenting formulas like this, and they're certainly well known. They've been around for some time. A lot of schools don't bother going anywhere near this stuff. They pretty much they try to do it much more simpler. But again, it's something that I go through, and you may want to look at that video. And you also may want to look at the video of somebody else doing it. I can't remember how they did it, but I'm sure they used these formulas too to come up with the R1, R2, and R3. All right? So not to come up with it, but to come up with an algorithm to figure out what the area was. So I went through it, and again, I know it seems like a lot of work to you, but it's something you want to pay attention to. And I got an answer to it, and the answer I got for the area was 6. Go figure, a nice number. But I want to check out some Sage code over here. And the Sage code is this over here, and I'm going to go through that with you. Let me clear the screen. I'm going to do a reset. And I'm going to go back over the problem again to go through that with you. X equals, and I'm saying R equals. Now I'm using Sage differently than I did the problem, and R equals solve that cubic polynomial for X. All right. Now you may be surprised to know that I can display R, but look kind of odd when I do that. I get 3, 4, 5. That's not so unusual. Again, if you went through the problem, you can actually solve that pretty easily through some pretty basic math, by the way. So what I want to do is I want to copy paste this over here, and I'll explain to you what this stuff is. All right. And this is using Heron's formula. This is what's called the semi-perimeter. I'm adding the three numbers together, 4, 5, 3, and dividing by 2. That's half the perimeter of that triangle. Now you notice the code over here, R0. R0 means the first element. Well, the first element of this is actually 4. When I do the dot RHS, that's right-hand side, would just be 4, so forth and so on. So you get 4, 5, and 3. Semi-perimeter, let me display that for you. Well, I could probably do that in my head, 4 and 5 is 9 plus 3 is 12, and divided by 2 would be 6. Well, as expected. And then I want to do area. I'm going to do a copy paste. I'm using Heron's formula. Oops. And let me just go through Heron's formula again with you, and it's written up in the notes if you want. Semi-perimeter times, the semi-perimeter minus the first side, semi-perimeter minus the second side, blah, 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 and a product, and you take the square root of that, and you'll get what the area is. I'm going to display A. Well, lo and behold, it's 6 again. All right. So over here, the rest of the code is just me displaying A, displaying S, displaying what the R0. Let me go through that. R0. Right-hand side. That's 4. If I want to do R1, I'm going to use the up arrow to do that. Type over the 0, make a 1. I get the 5. And if I did R2, I will say this, though, it's a simple problem. And what do you mean by that? It's really easy to factor that. You may not realize that, but it's an easy factorization problem. And what do you get? X minus 3, X minus 4, X minus 5. Again, someone says, well, what if they made a problem a little more difficult and it wasn't so easy to factor? So one of the assumptions made up front that you had 3 numbers, R1, R2, R3, that actually formed a triangle. That's not always true. I mean, you can get 3 numbers like that are in order like this, where R1 is less than R2 and R2 is less than R3, that wouldn't form a triangle. But again, you're assuming that they're giving you truthful information and you get the answer. And again, it's pretty simple. You'd have to go through this Viette's formula to do that, but it's something to learn. And if you haven't seen that before, I would recommend you click on this thing over here and watch this video, all right, about Francois Viette, The Birth of Algebra. All right, it's an interesting character. Thank you.